Hi everyone, the topic for this video is probability problems involving permutations and combinations. So in this section we're going to pair together the two pieces of this unit. We know how to count larger problems using permutations and combinations, and then we've also talked about the basic concept of probability. So when we try to calculate probability, we've used simple listing methods. For instance, if we had the sample space of numbers that appear on a single die, that's easy enough to list out. And then when we go to calculate probability, recall that this is just the number of outcomes in the event divided by the number of outcomes in the sample space. So if we wanted the probability of drawing an odd or rolling an odd number, for example, then there would be three ways to do that. All right, get a 1, a 3, or a 5. And then the number of outcomes in the sample space, we can see that that's 6 just by listing those out. In this section, we're going to deal with probability problems that have a larger number of possibilities. So think back to the counting problems we did where we had hundreds, thousands, or even millions of possibilities. So we'll use combinations and permutations to find these two numbers of things, the numerator and the denominator. Okay, so let's look at an example. Stacy has the option of selecting 3 books to read for a humanities course. The suggested book list consists of 10 biographies and 5 current event books. She decides to pick the 3 books at random. Find the probability that all 3 books will be current events books. Okay, so we need our event, the probability of choosing 3 current events books. All right, well, what is the sample space? The sample space would be all of the possible combinations of 3 books that she's picking. Combos of 3 books. All right, well, think about the number of possibilities. She has 10 biographies and 5 current event books to choose from. So this is like finding the combinations of 15 books chosen 3 at a time, or 3 out of 15 books. All right, and using combinations, there are 455 different options. So it's not really possible to list all of those out, so that's why we're using this formula. Okay, how about the probability of choosing 3 current event books? Well, how many ways are there to choose 3 current event books? Well, she has 5 current event books that are possible, and she's choosing 3 of them. Okay, so there are 10 different combinations of 3 current event books. All right, so then probability, we're just combining these two pieces of information, and we know that there are 10 ways to choose the correct combination that she wants out of 455 ways to choose just 3 books in general, not considering which type they are. All right, and then as a fraction in lowest terms, that's 2 out of 91, or as a percent, that's about 2.2%. Okay, let's look at another example. There are 12 women and 8 men in a seminar course. If the professor chooses 5-person groups at random, what is the probability that the first group chosen will consist of all women? All right, so we have the probability of choosing all women. Okay, so that would be the number of ways, let me abbreviate, the number of ways to choose all women. All right, well, this is a 5-person group, so in other words, the number of ways to choose 5 women, okay, divided by the sample space, or in other words, the number of ways to choose 5-person groups. Okay, so we know the number of ways to choose 5 women, well, there are 12 to choose from, so that's 12, and then choosing 5 of them. and the number of ways to just choose 5 people in general, considering all of the combinations. So this time we ignore whether or not someone is a man or a woman and just say that there are 12 plus 8 or 20 people. And we want to look at the number of ways to make combinations of 5 of those. Okay, and then working out those formulas, that gives 792 over 15,504. So you definitely don't want to list something like this. All right, and then in lowest terms, that's 33 over 646. So that would be a good answer. Or you could also convert to a decimal or a percent. As a percent, that's about 51%. All right, example 2 from the textbook. What is the probability of getting 4 aces when drawing 5 cards from a standard deck of 52 cards? All right, so the probability of 4 aces is the number of ways to get 4 aces. Divided by the number of ways. Right. So now we look at the sample space, or in other words, what is this probability experiment that we're doing? And we're drawing 5 cards from 52. So the number of ways to choose 5 cards. Okay, the number of ways to choose 4 aces. Well, how many aces do you have in a deck of cards? Well, there's 1 for each suit, so that would be 4 aces possible, and then we want to choose 4 of them. Okay, so in other words, you want to get all 4 aces in the deck. And I'm guessing this is going to be a fairly low probability. Right? That would be a logical guess. You know, it's pretty rare that you would actually get all 4 aces. So we'll see if the numbers work out. And then the number of ways to choose 5 cards. So we have 52 cards total, and we're trying to choose 5 of them. Okay, so choose 4, there's only one way to do that. All right. Oh, one other step here. Let me back up. So far, this one's a little different than the last one. We've chosen our 4 cards, our 4 aces, but we also have to take into account the fact that there's still a 5th card to be picked. All right, so there's not just one single way to choose 4 aces and another card, right? Because that 5th card could be any of the ones that are left. Right? So we need to add on to this and multiply by how many ways there are to choose the other card. Okay, so it's, if I correct this, it's more like number of ways to choose 4 aces and 1 other card. Okay, so the number of other cards that we have, 48 other cards, right? That's 52 minus the 4 aces because they've already been picked. And then we need to choose 1 of those cards. Okay, that's correct. So there's 1 way to choose the 4 aces, but then there are 48 ways to choose the other card. And then 52 choose 5 is 2,598,960. As a fraction in lowest terms, this would be 1 over 54,145. And then let's do a percent. This would be about 0.0018%. All right, a pretty slim chance of getting all 4 aces. Suppose the deck of cards in example 2 has all 32 cards with numbers less than 10 removed, so that only 10s, jacks, queens, kings, and aces remain. Now what is the probability of getting 4 aces when drawing 5 cards? Okay, so we still want to choose 4 aces and 1 other card. And then we still want to know the number of ways there are to choose 5 cards. Okay, so what else is the same here? The number of ways to choose 4 aces. Well, the deck that remains, we have, let's see, 32 cards were taken away, so that leaves us with 20 cards total. We've left all of the 10s, jacks, queens, kings, and aces, so we still have all 4 aces. All right, so the ways to choose 4 aces, there's still 4 to pick from, and we're picking 4 of them. Okay, now the ways to choose another card. Well, once you've chosen the 4 first cards here, all right, then that only leaves 16 other cards to choose from. Okay, 16, and we want to choose one of those. All right, how about the number of ways to choose 5 cards? Now there are 20 cards total, and we want to choose 5 of them. All right, so a couple of notes about this, things you can check to make sure your formula is set up correctly. If you're choosing 2 different things, like here we've got aces and other cards, then you're going to use the fundamental counting principle and multiply between the 2 combinations. Notice that the 2 n's in the numerator should add up to the n in the denominator. All right, so we're kind of like taking that total of 20 and just splitting it up and looking at 2 separate categories. Within those 20 cards, we've got the 4 that are aces and the 16 that are other cards. And then similarly for the r's, all right, the 2 r's in the numerator should add up to the r in the denominator. So if you're choosing 5, we're splitting it up and saying, okay, 4 of those are aces, and the other one is something else. All right, so that's the setup, and then we're just left with the calculation. I'll put that up top here. All right, 4, choose 4. All right, that's 1. 16, choose 1 is 16. And 20, choose 5 is 15,504. So in lowest terms, that's 1 over 969. That would be a good answer. Or if you want a percent, that's about 0.1%. Okay, so a little bit more likely once you have that smaller deck. Okay, we'll stop there, and I will make another video for you with some additional examples, and I also want to look at using permutations. The last examples just used combinations and the fundamental counting principle, so we'll look at some examples that deal with counting things in a certain order. All right, thanks for watching.